Hi everybody, welcome to today's GCSE Maths live group tutorial with our tutor Molly. Today's session is on simultaneous equations. So welcome. If you've joined us before, you'll know now how these work. Welcome if you haven't joined us before. You can ask Molly questions throughout using the chat feature. She'll be able to see that throughout. And don't worry if we miss one of your questions, we'll go back and have time for some questions at the end. So just let us know if you have anything you want to flag or want to go over at the end, we can definitely do that. So today's session is led by Molly. Molly is one of our top tutors at my tutor. She studies computer science and mathematics at Bath University and has completed over 150 lessons with us. So today's set to be a really great tutorial. And if you're ready, Molly, let's kick off.
Yeah, cool.
Yeah.
Okie doke. So we're doing simultaneous equations today. So one that's often quite tricky, or one that people often get a bit caught up on. And we're going to go right up to some level 8-9 questions as well. So we're going to start at a basic level and hopefully in this hour cover everything. Hopefully. So we'll start off with why on earth do we do them? I always think in maths, it's never really properly explained why you're doing things. And it's a lot less frustrating if you know why you're doing it and not just for the sake of it. So far in algebra, we've had a look at solving equations, one equation in one variable. So for example, 2x plus 3 equals 9 or something. I mean, it's just one equation, but we've just got one unknown, that x. And now what we're going to look at is when we have two equations with two unknowns. So we've got if we just had one equation with x and y, there are tons of different possibilities for what x and y could be. But when you throw another equation into the mix, a different equation with the same two unknowns, we can do some fiddling around with them and work out the distinct values for what those are, which is really cool. So what I'm going to do is start with the process of how we actually do it. And then when we look at some word problems, hopefully it will make sense how this can actually be applied to the real world, and yeah, why on earth we do it. So we'll have a look at a basic example. If some of you are in younger years, you might not have seen this before. If you're in older years, you might have, and this first bit might be really boring, but we'll get to the harder stuff. So this is what I mean by two equations and two unknowns. So something like 3x plus 2y equals 25. And 3x minus 4y equals minus 5. So if we just had one of these equations by itself, we can't do anything with this. Because like I said before, there are lots and lots of different possibilities for what x and y can be. And what I'll do after this question is I'll quickly show you one on a graph. I always like to show things in a couple of different ways, and I think sometimes on a graph it can actually make more sense what's happening. But the basic thing that we do with this is that we want to combine these equations in some way. We want to do something involving both of these equations to work out our values. So what we can see here, so I always number my equations, so number them 1 and 2, because then this allows us to be really clear and keep track in our minds of what we're doing. So we can see that we've got a 3x in both of these, which means that if I do something that seems a bit weird, if I do the whole of equation 1 and subtract the whole of equation 2, so that means doing it by element. So the x is here minus the x is here, the y's minus the y's, and the constant minus the constant. Then I'm going to end up with an equation that's just in y. So because we do 3x minus 3x, that cancels out that x. And then I do 2y minus 4y, which gives us 6y, and then equals 25 minus 5, which is 30. And then dividing by 6 on both sides gives us that y is equal to 5, which a few of you already got in the chat, which is awesome. Now the thing with simultaneous equations is knowing that y equals 5 is great, but we need to find x as well. Sometimes we'll do them where we cancel out the y, so we'll get x first, just plug it back in to get the other variable. That's what we're going to do. Now both of these equations are true, so it doesn't matter which one we plug it into. I'm going to choose the first one. And what we do is we say, well, we don't know x, so that's 3x. When y is 5, 2y is 10. So 3x plus 10 equals 25. So subtracting 10 from both sides gives us that 3x is 15. And then dividing by 3, x is 5. And we can test this. They're both 5, right? So 3 times 5 plus 2 times 5, that's 15 plus 10. Yeah, that's 25. 3 times 5, that's 15, minus 4 times 5, so minus 20. Yeah, that's minus 5. So these are the two values for which both of these equations are true. Yeah, loads of people got it right. Awesome. Now, as promised, we'll have a look at one that's on a graph. Hopefully, if I can get these tabs to work. The reason I can't go through loads of these is because it's very hard to draw accurate graphs on here. But hopefully one example should kind of show you. Okay, so here we've got the lines with equations 3y plus 2x equals 12, so that's this one. And y equals x minus 1, that's this one. Sometimes the question might say, using by plotting the lines on graphs, solve these equations. So the equations that we're looking to solve are literally just these two that have been plotted. So another way that we could write that is solve 3y plus 2x equals 12 and y equals x minus 1. Now, at every point, if we just look at this equation, 3y plus 2x equals 12, that's this line. That means that at every single point along this line, 3y plus 2x is equal to 12. For example, let's pick this point here. 3 lots of y is 3 lots of 0, plus 2 lots of x, so 2 lots of 6. Yes, that is equal to 12. And we can pick lots of different points on here. And similarly, along this line, at every single point, y is equal to x minus 1. So at this point, y is 4, which is equal to the x value 5 minus 1, and so on. So where do you think these two are equal? Yeah, the one on the graph is just similar to linear equations. And someone said, well, we do simultaneous equations by substitution. Yes, we will, near at the end. Yeah, loads of people are getting this right. Awesome. It's where they meet, where they cross. Brilliant. Because at this point, this is the only point here where both of these things are true. Hopefully that makes sense. It will be this point here, and we can see that at this point, x is equal to 3 and y is equal to 2. Ooh, that was a bad x. X equals 3, y equals 2. And we can solve this as well. What we'll do is we'll solve this equation using our algebraic method that we just learned, just to show that doing both ways gives you exactly the same result. So what I'm going to do here actually is start to introduce what substitution is. So what I'm doing now is throwing loads of methods at you. So don't worry if you're getting confused or not following. I'll do loads of examples of each method. So this is what's meant by substitution. So these are our two equations. Now, if we look at this second one, we can see that y is equal to x minus 1. So that means, why not, wherever we see a y here, just replace it with x minus 1? I'll show you what I mean. 3 lots, and I'll do it in pink so we can see where it's come from, of x minus 1 plus 2x equals 12. So all I've done is where I've seen a y, I've written x minus 1. Because our second equation tells us that we can do that. They're the same thing. Y and x minus 1 are equivalent. So all we've done is replace it. And now we've got one equation in one variable. There's only x here that's unknown. So now we can solve this in our usual way. We'll expand out here. So 3x minus 3 plus 2x equals 12. Combine the x terms, 5x minus 3 equals 12. 5x equals 15. So x equals 3. Hopefully you followed that algebra there. Let me know if you want me to do the algebra a bit slower. Now we've got x equals 3, we'll plug it into one of our equations. Now I'm going to choose to plug it into our second equation here. I should have labelled these, apologies. I'm going to choose to plug it into equation 2 because that looks a lot nicer. So equation 2 tells us that y equals, well, our x value is 3 minus 1. So y equals 2. And look at that, we've got x equals 3 and y equals 2, which is exactly what the graph told us. So that's just kind of demonstrating the multiple ways that you can do it. Okay, let's have a look at another few. So let's have a look at this one. 2x minus 5y equals 11, and x minus 4y is equal to 4. Now this one we can see looks a bit trickier because, well, we can't immediately see. With our first one we had two values that were 3x, so we could just subtract one from the other. Here we can't really see what to do here. So what we're going to have to do is manipulate these equations a little bit ourselves, play around with them so that we can cancel something. So I'll label them again. And what I'm going to do is, well, wouldn't it be nice if this was 2x? Because then we could just do a straight subtraction like we were doing before. So let's make it 2x. Well, to do that, we need to times it by 2. So we need to times the whole equation by 2 so that nothing is really changed. If we times every element of the equation by 2, it's the same equation. So what I'm going to do is I'm going to write out what I'm doing. So 2 times equation 2. This is just my notation. If it's in a circle, I call it, it's an equation. So 2 times equation 2 is going to give us 2x minus 8y equals 8. You see, I've just multiplied each of these elements by 2. And then I'm going to call this equation 3. So now all of these things are still true, but this form, equation 3, matches a lot nicer with equation 1. So what we're going to do is we're going to do our equation 1 minus our equation 3. And this is why I like numbering them, just so that you can see what's happening here. It should really have been an arrow, so it equals too much. So equation 1 minus equation 3, 2x minus 2x cancels out. Minus 5y minus 8y. So that's minus 5y plus 8y, which is 3y, equals 11 minus 8, which is 3. So y equals 1. But we're not quite done, because we need to now work out what x is. Now you can choose to substitute it into any one of these 3 equations that we've made, because all of them are true. So it doesn't matter which one we substitute it into. So I'm going to choose to substitute into equation 2, because that's just got a single value of x. So that feels like a lot less work that we need to have to do. So we'll have a look at that. So equation 2 becomes x minus, well, 4 times 1, which is our y value, is just 4, equals 4. So adding 4 to both sides gives us x equals 8. And there you go. There's our solution. X is 8 and y is 1. Yeah, brilliant. Loads of people getting that solution, which is really, really good. Cool. Okay. I'm going to go over one more, at least one more that's a bit tricky. Let's do a new page for this. Excuse me. So let's have a look at 2x plus 3y equals 30 and 3x plus 4y equals 46. Now this is one that the other two I'd pre-found from online. This is one that I came up with. So the numbers might be horrible fractions, but we're grown-ups, we can deal with it. So the issue here with this one, well, first of all, it's not like our first example, neither of them match up. And it's not even like our second example. We can't multiply, for example, the 2x to make it into a 3x. So what we're going to have to do is multiply both equations. Even more work for us to do. Now you can choose which you do. What we're basically going to do is make either this pair or this pair have the same coefficient. So what seems sensible is to either make these into 6x, so because we know that 2 and 3 go into 6, or make these into 12y, because 3 and 4 both go into 12. We could make this into 12x, because 2 and 3 both go into 12, but we'll keep the numbers as small as we can. So I'm going to make the x's into 6x, because that seems like it's a bit like easier multiplications for us to do. So I'm going to label my equations, 1 and 2. And then I always find this quite similar to making fractions have the same denominator. Like if you had something over 2 and something over 3, you'd try to make them something over 6. So it's basically exactly the same train of thought. I think that's interesting. So to get 2x to be 6x, we have to multiply it by 3. So we're going to do the whole of equation 1 times 3. And that's going to give us 6x plus 9y equals 90. And then for equation 2, well, we want that 3x to be a 6x, so we have to times it by 2. So we're going to times the whole of equation 2 by 2. And that's going to give us 6x plus 8y equals 92. And now we've got these two new equations which we've just formed, 3 and 4. And remember, these are perfectly valid equations because all we've done is times by 3. And now we've got 6x's in common. So we can do the first equation, so equation 3, subtract equation 4. We could do it the other way around. That would be totally allowed as well. That would just give us negative numbers. Well, actually, this will give us one negative number, but I always tend to make sure that my y is positive, or my x if I'm doing the other way around. So we're going to do equation 3 minus equation 4. And that's going to give us all the x's cancel out, and that's going to give us y equals minus 2. And then, remember, we're not done. I always slipped up so much on this, writing y equals 2 and submitting that as my answer. But you've always got to make a note at the beginning if you want to. Make sure you write find x and y. Simultaneous equations, you always need 2 solutions. So let's see which one's easiest to find x. I'm going to say probably equation 1, because it's only a 2x, so we're only going to have to divide something by 2. You could submit it into, substitute it into equation 4, if you're feeling a bit crazy, want to divide something by 6. Totally up to you. So I'm going to do equation 1. And see that this gives me 2x plus 3y, so that's going to be minus 6, because it's 3 times minus 2, equals 30. And then, adding 6 is going to give us 2x equals 36. So dividing by 2 gives us that x is 18. Hey, for an example I came up with, they were actually whole number answers. Pretty pleased with that. So x equals 18 and y equals minus 2 for this one. Yeah, brilliant. People got the answer to that. Someone said, would you ever get simultaneous equations with fractions in front of x and y? That's a really good question, actually. We'll do something like that. I've got a... is this one horrible enough? Yeah, probably. I've got quite a hard one with fractions here, which might be quite good. So we'll do this one. Cool. So let's have a go at this. So it is 4 lots of 2x plus y over 4 equals 38 over 2, and 5 lots of x plus y over 4. I'm actually going to change this slightly. Am I? Yeah. I'm going to, just because I want to prove another point, I'm going to make this minus 5 lots. It might make the answer worse, but over 4 equals 70 over 3. So these are our equations. So they don't look quite as nice as they did before. But the first thing that we can do, and this is a key thing to remember, is that we can actually simplify the equations before we start, if we want to. So for example, this first equation, before I even call it equation 1, I'm going to make it nicer. I'm going to write it as, well, this 4 is going to cancel out with this 4. Because if we divide 4 by 4, we get 1. So this side of the equation here is just 2x plus y. And 38 over 2 is 19. Well, that certainly looks a lot nicer. Unfortunately, there's not really much that we can do about this equation here. I'll show you a couple of things. We can write it to start with like this, minus 5 over 4 lots of x. Sorry, not plus. Minus 5 over 4 lots of y. So that's just kind of expanding this out, equals 70 over 3. So there are a couple of routes that we can now choose to go with these. These are our equations. 1 and 2. What we could either do is we could multiply this equation by 5 over 4. And that's what I might do, to be honest, because then we've got y equals 5 over 4 and we can combine these. Or we could multiply this equation all by 12. Now that sounds really weird. I'll explain what I mean. The reason that we could do that is because it would be like, if we times everything by 4, we get rid of these 4s down here. And then if we times everything by 3, we get rid of the 3 here. And it basically gets rid of the fractions. So what I'm actually going to do is I'm going to show you both of those methods, I think. So I'll start off with my method of multiplying the first equation by 5 over 4. Now we can either multiply it by 5 over 4 or minus 5 over 4. I'm going to multiply it by just 5 over 4 so that I'm less likely to go wrong. And I'll show you what that means that we do. So equation 1 times, that's definitely a 2, and 5 over 4. Someone said, would this be on a calculator paper? I'm not sure. This could be non-calculator because you do need to be able to work with fractions. And somebody said, how did you get equation 2? I multiplied out this. So this is actually the same as saying that it's minus 5 over 4 lots of x plus y. Because minus 5 and x plus y are multiplied, that over 4 is kind of applying to either one of them. We can split it up a bit like that. Cool. So yeah, I'm going to do this multiplication here. So this first equation times 5 over 4. Well, 2x times 5 over 4. You know what? I'm actually going to write. I'm going to do it in a bit more steps because I know that fractions can be a bit confusing. So that all that means is 5 over 4 lots of 2x plus 5 over 4 lots of y equals 5 over 4 lots of 19. So I really have just written 5 over 4 in front of everything. I've just multiplied everything by 5 over 4. And now I'm going to make it look a little bit nicer. So I'm going to, with this one, 5 over 4, I'll write what it is and see if you can see it. This is going to be 10x over 4. And the reason for this is because when we multiply, this is as if we're multiplying by 2x over 1. So we just multiply the top. So it becomes 5 times 2, which is 10x over 4. But we know that we can do a bit better than that because this is going to simplify to 5x over 2. Because 10 over 4, if we divide the top and the bottom by 2, we get 5 and 2. So hopefully you can see that this is going to be 5x over 2. And then, actually, what I will say is because we know that we have to combine the x's, it might actually be sensible to leave it over 4 because this one's over 4, if that makes sense. So yes, that does simplify to that. But kind of makes sense to leave it like this because it'll be easy to combine. Hopefully you'll see in a moment. 5 over 4y we're going to leave as it is. It's basically what we want it to be. And then 5 over 4 lots of 19. We can do it in a similar way to how we worked out this one. We can say it's like 5 times 19 over 4. And that is equal to 95 over 4. It's 95 over 4. So now this is our equation 3. So let me zoom it out. Oh, I can't zoom out any more than I have, but there you go. You can see equation 2 and equation 3. We've got a 5 over 4y here and a minus 5 over 4y here. Let me just check the chat in case. Someone asked me to slow down. Yes, I will. Sorry. Yeah, okay. People are finding this one quite confusing. Okay, I might go over another fraction one, maybe at the end, if we need to as well. The reason that I multiplied it by 5 over 4 is because we wanted to match it to this 5 over 4 with the y here. So it's as if this had been like 3y, we times this whole equation by 3, right, to get the 3y's to match. Just because it's a fraction doesn't mean we're going to do any differently. We're going to multiply this by 5 over 4. So what I'm going to do now is I'm going to add the two equations because we've got a minus 5 over 4y and a 5 over 4y. Let me just circle the two equations that we're now using actually, because there's a lot of writing on this screen and this might make it a bit clearer. So we've got a minus 5 over 4y and a 5 over 4y. So when we add them, it's going to become 0. It's like if we had a minus 2 and a 2. If we add them, they become 0. So when we add these two equations, and I haven't left myself with much room here, we're just going to have to do some horrible fractional adding. So let's write out first of all what we're doing. Let's section this off. We're doing equation 2 add equation 3. And that's going to give us, well, this is why I left this one over 4. Minus 5x over 4 plus 10x over 4 is going to give us 5x over 4. I don't want to dwell too much on the fractions because I did do a lesson on fractions last week. We know that the minus 5 over 4y plus 5 over 4y is going to cancel out. So we just say that this is equal to, and I'll write this one out first. So 70 over 3 plus 95 over 4. If people are still confused, I'm going to do this question in a second different way. So hopefully that will make a bit more sense then. So don't worry if this one is confusing you. I'll show you the second way in a minute and maybe that will make more sense. And then this basically we're going to do some horrible, I might actually leave this one here unless people have answered it. So we're going to do some horrible adding here. Adding of fractions here. So I'm going to times 70 over 3 by 4. I'm going to give them both a denominator of 12. So 70 times 4 is 280. And then I'm going to times this one by 3. So 95 times 3 is 285. And then add these. These are really horrible questions, this. I don't think you'd get one like this. Or if you did, maybe do the second way that I'm about to show you, but this is always good practice. So then when we add these two equations together, we get 565 over 12, I think. Yep, so we get 5x over 4 equals 565 over 12. So basically, I'm going to use a calculator for this, unless, do shout if you actually want me to go over it. But so we have 565 divided by 12 times that by 4, divide that by 5, so x is equal to that, 37 2/3. And you would do the substitution back in, which I'm not going to go through because all it would be at this point is just complicated complicated fraction work, which we don't need to do. So I'm going to just go through this in the second method just because I think that this way might be a bit easier, or I'll at least set up the second method for you. So what I was saying was, hopefully you understand how we got to these. These are basically just the original two equations. And then what I was saying was that we're going to make equation 2 look a lot nicer, a bit more linear. So we'll start by doing equation 2 times by 4, because that's going to give us minus 5x minus 5y equals 280 over 3. That's basically to get rid of these 4's down here. We times every element by 4. And then we're going to times every element by 3. So minus 15x minus 15y equals 280. And now we've got, I'll circle them in blue, we've got this equation and this equation, which hopefully look a lot more familiar to you as kind of two linear equations that we could solve. So does that way make a bit more sense? No, the 280, someone said much easier. Okay, that's good. Yeah, the only reason that I wanted to show the other way was because sometimes this way might be easier. I think in this case it definitely wasn't, but it's good to show you anyway. And now we've got these two equations in blue, which are just some linear equations that we can solve. And I will go through them at the end again, if you would like me to. I'm going to move on to some word equations now. If you're still confused, whack a message in the Q&A or in the chat, and I'll come back at the end. So let me, cool. Oops. Got my own face in the way of me screenshotting this question. There we go. So, an equation such as this. So, hopefully you can, oh gosh, I can't see if I do that, right. Hopefully you can see it now. So, the sum of ages of an aunt and her niece is 28. In 4 years' time, the aunt will be 3 times older than the niece. How old is each person at present? So this doesn't look like it's simultaneous equations at all. It's not what we're used to seeing. But if you ever get a horrible word question like this, I encourage you to assign some things, some letters. You know, maybe let's call the aunt's age A and the niece's age N. That seems to make sense. That feels intuitive. And then just write some equations based on what we have and see what we can do with it. So the sum of ages of an aunt and her niece is 28. Easy. There's one equation. Now remember, we can't solve anything from this. It could be anything. You know, she could be 26 and 2. She could be 27 and 1. We don't know. In 4 years' time, the aunt will be 3 times older than the niece. Now this one is really, really hard to think about. So the forming the equations is actually the hardest bit here. So, well, in 4 years' time, let's think about how old they'll both be. So A and N are their current ages. So in 4 years' time, the aunt will be A plus 4, and the niece will be N plus 4. Right? That's just, we're adding 4 years to both ages. Then the aunt is 3 times older than the niece. So that means that the aunt, aged in 4 years' time, is 3 times the niece's age in 4 years' time. Hopefully that makes sense. I know that it's quite confusing kind of forming that equation. Some people are already saying some things, which is good. I think I'll come back to that fraction question at the end because there's a lot of questions. So A plus 4 equals 3 lots of N plus 4. And here are our equations 1 and 2. And in fact, I'm going to simplify this question a little bit and write it more in the form that we're used to. So let's see what we can do to this. A plus 4 equals 3n plus 12. All I've done there is expand out. And then I'm just going to get the a's and the n's on the left and everything else on the right. So a minus 3n plus 4 equals 12. all I've done there is subtracted 3n. And then a minus 3n equals 8. And that's just by subtracting 4 from both sides. So now we have this new equation, which we'll call equation 3. And now, hopefully, you can spot that we can do equation 1 minus equation 3, because they both just have an a. So that's how we'll get that to cancel out. So we say equation 1 minus equation 3. And that's going to give us all the a's cancel out. N minus minus 3n is 4n, equals 28 minus 8, which is 20. So n equals 5. Brilliant. And then we'll just have a quick look at one of our equations to see what a is going to be. Well, we know that their ages add up to 28, so we know that a plus 5 equals 28. So a must be 23. So at the moment, the aunt is 23 and the niece is 5. And we can actually, these are really nice to check, which I think is really cool, especially with the word problems. So let's check it with what we have. The sum of the ages of an aunt and niece are 28. Yep, they are. In 4 years' time, the niece will be 9 and the aunt will be 27. And in fact, 27 is 3 times 9, so that works. Perfect. Hopefully that makes sense. Yes, I will try to go slower. Sorry, I naturally talk very, very quickly anyway. I'll go slower with the next one. Somebody asked again how I got this. This is because in 4 years' time, the aunt will be her current age plus 4, and the niece will be her current age plus 4. So these are their ages. And then at that time, the aunt will be 3 times older than the niece. So the aunt's age in 4 years is 3 times the niece's age in 4 years. Okay, awesome. Okay, we'll go through, let me see what time we're on. Yeah, I'm going to go through one more word question and then I'm going to do some more substitution ones. So, okay, here's a good one. One second. Okay. So, again, I'm going to read through it once and then read through it again, writing down things as I go. I've said it before, I feel like that's always the best way to approach questions where you're not quite sure where to start. So the mean of two numbers is 51.5 and the difference is 19. And we want to calculate the product of the two numbers. So to calculate the product, well, let's find what the two numbers are first. Let's give them names. Let's call them, let's be really creative and call them X and Y. So those are our numbers. So let's have a look. The mean of two numbers is 51.5. Now, how do we calculate the mean? Well, we add them all together and then we divide by how many numbers we have, X and Y. We have two numbers. So this is how we calculate the mean. You add them, you divide by how many there are. And that mean is equal to 51.5. Now let's have a look at the second bit. The difference is 19. Well, let's just call X the bigger one. Because we've just kind of assigned them X and Y, we can assign them either way around, so it doesn't matter. Yeah, so it doesn't matter which ones, because we've just assigned them X and Y. We can just say that the difference, for example, X minus Y equals 19. Cool, so now we've got two equations that we found from this. What I am going to do is just, hopefully you can see that we can make this equation a bit nicer. Now, how do you think we can make this equation nicer? Yeah, times it all by 2. Cool, well done. So that gives us x plus y, because when we multiply something that's all divided by 2, if we multiply it by 2, it just becomes itself. And then 51.5 times 2 is 103. Now I'm just going to rewrite this equation underneath. We've got our 2 lovely equations. Equations 1 and 2. So there are a couple of things that we could do here. We could either subtract one from the other to cancel out the x's. But what I'm going to do is add them together, because firstly, I prefer adding. And secondly, it means that we won't have any risk of dealing with negatives or anything like that, because we've got a plus y and a minus y. When we add them together, that's going to disappear and become 0. So equation 1 plus equation 2 is going to give us 2x, adding those 2 x's together. The y's, like I said, cancel out. Y minus y equals 0, so that's gone. So equals 103 plus 19, which is 122. So then to find x, we have to divide both sides by 2. So x equals 61, which I know some of you are saying, which is really good. And then we can simply substitute this into one of the equations. We can substitute it into either equation. So I'm going to do it into equation 2, because 2 is my favourite number. It really doesn't matter which one. So equation 2 tells us that 61 minus y equals 19. All I've done there is I've taken my value for x and I've popped it in there. And then we can rearrange this to find y. Well, this is going to tell us that 61 equals 19 plus y. So y is going to be 61 minus 19, which is 42. Yeah. Told you I don't like subtracting. Awesome. And then as our answer, we just multiply these 2 together, which I'll just show you quickly because it's not the point of this session. 2 times 2 is 2, 6 times 2 is 12, add the 0. I know I did that really, really quickly. It's literally just because I want to get to more simultaneous equation stuff. So it's 2,562. Yeah, brilliant. Everyone did that really well. Someone said, how do you know when to add or subtract them? Are there rules to know what to do? Not really. It's just what I could also have subtracted these. It's just personal preference. It's kind of whatever you want to do. As long as what you do works and is mathematically sound, you can do whatever you want. Okay, it's almost coming up to time to take the questions. I'm just going to do one more because I've kind of been taking a lot of questions as we go along, because I'd like to do some that use substitution, make it more with some quadratics, if I can get to this. Cool. So what I'm going to do is this one, and then I guess in a few minutes we'll take questions. So hopefully all the linear ones make enough sense, excluding perhaps the fraction one, but maybe go back and watch it again and see, because I do talk very quickly and I'm sorry about that. Do keep yelling at me if I go too fast. So now we've got one where this one has a horrible x squared in it. Disgusting. What on earth are we supposed to do with this? Well, we're going to do something that I touched on before, substitution. So we know that this is equal to y. So why not in our first equation just substitute in every time we see a y, we write x squared plus 2x minus 3. Because that is what y is. This equation tells us that those two things are the same. So 3x plus, and then I'll write it in a different colour so that you can see where I'm coming from, x squared plus 2x minus 3 equals minus 9. All I've done is instead of writing y, I've written this, which is perfectly allowed because they're the same thing. So now we can make this into an equation that we're familiar with solving. I'm going to combine the x's, so help if I wrote with a pen. X squared plus 5x minus 3 equals minus 9. So all I've done there is I've combined the 3x and the 2x. And then if you remember the lesson, or if not, maybe go and have a look where I did solving quadratics, we're going to make it equal 0. So x squared plus 5x plus 6 equals 0. And then we're going to factorise. Again, go and have a look back at the previous lesson if you don't remember this. So this is going to be x plus 3, x plus 2 equals 0. And that's because 3 and 2 multiply to make 6 and add to make 5. Now we've got two options for x. So when you do quadratics with substitution, it's a bit more confusing. We've got x equals minus 2 or x equals minus 3, because it's whatever makes one of these brackets 0. So then we're going to have to do two cases. So I'm going to substitute into the first equation. So when x equals minus 2, the first equation becomes 3 lots of minus 2 plus y equals minus 9. So minus 6 plus y equals minus 9. So y equals minus 3. I know I did that really quickly. I want to get on to taking questions, that's all. And then when x equals minus 3, 3 lots of minus 3 plus y equals minus 9. Minus 9 plus y equals minus 9. So y equals 0. So then, and this is crucial, our solutions are either x equals minus 2 and y equals minus 3, or x equals minus 3, y equals 0. So that's how you solve them like that with substitution. So now I'll take some questions. Okay, a lot of the questions on the Q&A are just people saying that they don't understand. If you could be more specific about which ones.
Yeah, hi everyone. If you just pop in the chat a particular question or a particular type of question you want to go over, then maybe for the last sort of 5-10 minutes we can do that, because it seems like people would like to go back. So just let us know what you'd like to go back to, and then we can have a look through that and do that.
Okay, a lot of people saying the fraction one. Sorry, go on.
Yeah, brilliant. Yeah, let's go back to that. And just for the person asking where you can find the videos of the previous lessons, they're on the My Tutor YouTube channel, as well as linked on the site for our online school. So you can, if you just type in My Tutor into YouTube, then all the previous webinars are there, and you can access those, and then the ones from today will also be uploaded there.
Okay, cool. So I'll go back over the fractions one, and I'm going to do exactly the same question. I'm going to do it a lot slower, and I'm only going to do the second method. If you're interested in the first one, go back and have a look, but I'm only going to do the second method. So the question itself was 4 lots of 2x plus y over 4 equals 38 over 2. And 5 lots of x plus y over 4 equals 70 over 3. So I'm going to simplify both of these equations down before I try to do anything regarding simultaneous equations. So I'm going to take them one at a time and simplify them as much as I can to try to eradicate the fractions, basically. So I will start with this one. Now, first of all, looking at the left-hand side of the equation, we can see that we've got 4 lots of something that's then being divided by 4. So these 4's cancel out, and we're just left with 2x plus y on the left-hand side. Hopefully that bit makes sense. And then on the right-hand side, well, 38 over 2, we can simplify to a whole number. 38 divided by 2 is 19. So hopefully that makes sense. That one, okay. And now we're going to have a look at this one, which is much more complicated and I think was causing a lot of the confusion. So what I'm going to do with this one, before I expand anything out, I'm actually going to go straight into removing those fractions. So the way that I'm going to do this is I'm going to start by multiplying both sides by 4. Now the reason I'm going to do that is because if I multiply the left-hand side by 4, I get rid of the 4 on the bottom here. So multiplying this whole thing, if you multiply anything that's divided by 4, if you multiply it by 4, you get rid of that bottom bit, basically. For example, that's kind of what we did here. But we were multiplying by 4 on the top, which got rid of it. So if I do that, what I get is 5 lots of x plus y equals 280 over 3. Because that's what 70 over 3 times 4 is. Because when we times a fraction by 4, we just times the top bit by 4. Because it's as though we're timesing by 4 over 1, so the denominator is just multiplied by 1. So I also realized that before I made this question minus. I'm just keeping that out for now so that we can just focus on the fractions. So this is actually a slightly different question than before, but it's essentially the same. Okay, great. Now I'm going to get rid of the 3 here so that we don't have to work with a fraction here either. So I'm going to multiply both sides by 3. So multiplying the right-hand side by 3 is going to just leave me with 280. And multiplying the left-hand side by 3 gives me 15 lots of x plus y. And that's because 5 times 3 is 15, so we're just timesing this bit by 3. Now, before I expand out, I can actually make these numbers even simpler for myself. You could just work with this, that's totally fine, but just to make it a bit easier, we can actually now that we've got it linear, we can divide both sides by, let's say, 5. Because we know that we can divide 15 by 5 and we can divide 280 by 5. So why not make it simpler for ourselves? Just like we made it simpler here by multiplying, let's make it simpler by dividing. So dividing 15 by 5, we get 3. And dividing 280 by 5, we get 56. And now that we can't simplify anymore, we're going to expand out these brackets. So multiply everything in these brackets by the 3. So we get 3x, plus 3y equals 56. And now, if we take these two simplified versions, so this is our simplified version here, this is our simplified version here, and if we take these and just pop them over here, I'm just rewriting them, 2x plus y equals 19, 3x plus 3y equals 56. Now I have something that looks exactly like the questions that I'm familiar with and comfortable with. I can label them 1 and 2 and go on to solve it as usual. Does that make a bit more sense? Yeah, okay, awesome. Sorry, I didn't go that slowly to start with.
That's great. Someone's just asked how many marks would simultaneous equations usually be on an exam, specifically AQA?
That's a very good question. It depends. So I can actually show you on maybe, I think I actually deleted the tab that I was using. I would say, so one like this would probably be 4 or 5 marks, maybe 5, because you've got to simplify the equations and then do them. Just a straight one, if you were just given these straight away, I'd say 3 marks.
Cool. There have been a few sort of requests throughout to go over particular separate topics to what we've covered today in other lessons. So thank you for those. I've made a note of those because it's useful to get your feedback on what's valuable for future lessons. So thank you for those. If you have any sort of last questions, just pop them in. Molly, do you think there's time to just go through one more?
Yeah, I think so.
Perfect.
Just if you pop on the chat, would people rather I go through one like this or one at the end with the x squared and the substitution? Which would people prefer? Oh gosh, okay, there's quite a mix. Maybe that wasn't helpful. Oh dear. Okay, I'm gonna do, oh my gosh, that's really 50-50. That's actually very stressful. Right, I'm gonna do, what I'm gonna try to do is combine them, which is maybe a silly idea, but I'm going to do it anyway. Or am I? Who knows? Let me just have a look at what quadratic ones I have on here. Okay, why don't I go, yeah, okay. I'm gonna do this one because I think that this combines them and there's clearly quite a 50-50 split for what people want. So these look horrible and that's because they are, but I'm gonna go over it. I have 3 minutes or so. We might go over a tiny bit, but I'm gonna try to not rush it. So we're going to do exactly what we did before and make each of these equations look a bit nicer. So we're going to start, I'll do exactly the same thing. We'll start with this one. Now we could leave this one as it is, but it's much nicer for us if we work with whole numbers rather than fractions or decimals. So if we've got a 0.5y, well, the way that we can make that into just 1y is if we multiply this whole equation by 2. So by doing that, we get 4x plus y equals 20. Hopefully you can see where I've got that from, the 2x times 2, 0.5y times 2, and 10 times 2. So I just did that so that it's nicer, there's no 0.5s in there anywhere. So that's all we had to do with this one. Now this second equation looks horrible, but we're going to do exactly what we did before and we're going to make it a lot nicer for ourselves. So we're going to start off by getting rid of the 3 that's here. Now to do that, hopefully you remember from last time, we're going to multiply both sides by 3. So we're going to get, well, on this side, it just makes that 3 disappear from the bottom. Oops, sorry, that should be a minus. And on this side, remember when we multiply a fraction by a number, it just multiplies the top. So we get 6y over 6 lots of x plus 4. Hopefully that makes sense. All I've done is I've just taken this 2y and I've multiplied it by 3. Now, hopefully you can see, and it doesn't matter if you don't see this because it doesn't matter where the simplification happens, but we can actually simplify this fraction as a whole just by dividing, just by these 6's cancelling out, because 6 over 6 is just 1, so these cancel out. So actually what we have is 2 lots of x minus 1 equals y over x plus 4. Sorry if I'm still going a little bit too fast. I don't want to run over too much, but I'm trying to go slower than I usually would. Then what we're going to do is, now it sounds horrible, we're going to multiply it by x plus 4 to get rid of it from the bottom of this fraction. It seems like a weird thing to do, but it's just as if, imagine this was a 5. You wouldn't hesitate in multiplying it by 5. It's no different when it's x plus 4. So we get 2x minus 2 times that x plus 4 equals y. Remember, multiplying up by x plus 4 just means it disappears from the bottom. I'm going to scroll down because we only need to look at this for now, but then I'll scroll back up. And now what we're going to do is expand this to give us something a little bit nicer. Yes, I'm going to do that. So we get 2 lots, and then I'm going to expand these brackets. So using the FOIL method. So x squared plus 4x minus 2x is plus 2x minus 8. If you don't recall that, go back and have a look at the quadratics lesson. And then just expand this out by 2. So just multiplying everything in the brackets by the 2. 2x squared plus 4x minus 16 equals y. What time am I on? Okay, it is 1/4 but I'll just be 2 more minutes. So we're going to see that we've got these two equations here, now that we've made them just kind of on one line with no fractions. And we'll write these out. 4x plus y equals 20, and 2x squared plus 4x minus 16 equals y. And now what we're going to do is one just like the last one that we did before I took questions. So look at this, all of this equals y. Sometimes you'll have to rearrange it to make it equal to y, to substitute it in. But what we can do is in this equation, wherever we see a y, we're going to write this. Because they're equal, they're the same thing, it doesn't matter. So 4x plus, we've got a y, so instead of y, we're going to write 2x squared plus 4x minus 16. And we finished our y, so that equals 20. And now this step I'm going to rush a little bit, but you can come back to it in your own time. 2x squared plus 8x minus 36 equals 0. I've just made that right-hand side 0 and combined everything on the left-hand side. We can divide everything here by 2 to make it nicer for ourselves. And then we've got an equation that we probably have to use the quadratic formula to solve that, I think. But anyway, yeah, so that is so that's another fraction example and another x squared example. And I've only finished 2 minutes late. So I hope that that makes it make a lot more sense now.
Awesome, thanks Molly. So I think we'll wrap up there. Someone's just asked how many marks would that be?
Someone pointed out that I swapped x minus 1 for x minus 2. Yeah, I don't know why I did that. So that probably would factorize if I hadn't been an idiot and done that. Thank you for pointing that out. A question like that one would probably be about 5 marks or so, maybe, yeah, 5 marks.
Awesome, you guys have got keen eyes there. So we've got tomorrow the math session is going to be an algebra roundup. So if you guys want to join that, sort of wrap up everything that's been happening the past few days. And then also we've got the first GCSE chemistry live tutorial happening tomorrow at 11 AM. So if you've also been joining us for our physics and biology sessions and were keen for chemistry, I know a few of you were, then please join us for that tomorrow at 11 AM. As usual, you should get an email letting you know the sort of timetable, and you can also check it out on the site. So thank you very much for joining today, and thanks Molly for another great session, and hopefully see you guys all in another session soon. Cool. Bye guys.
Thank you everybody. See you next time.